y'all? This is Coach Jay, Pre-Cal 12 podcast 7.1B. Here we go. And if you need some help on maybe how to start it, let me know. I know we were working through it there. Oh, you had some questions on that? All right, so remember from yesterday, right? Kind of format. A point of intersection is where two lines intersect, right? So that point is what we're solving for. Both of these are going to be lines, right? So they're like lines that intersect. So because of that, we can isolate one of the variables within this, right? What variable could we isolate? Either one of them, right? We just need to get one variable by itself. X. Yeah. So what could we do with the bottom one, Elijah? What would X equal here?
20 minus y.
Great job. Yeah. So since it's 20 minus y, and that is it isolated, we can then do what we call substitution, and we just take that value and just substitute it into the top one, right? So we're going to substitute it up top. And when we do that, what one does it go in for again on the top side? Exactly, yeah, we're going to substitute in for x. So it would be 1/5, and then literally what happens is this x goes away, and instead I plug in 20 minus y in for that x value, okay? So here we are. And then the rest of it I just write like normal, right? Hold up, this would be y, right?
What did I do?
Okay, remember that? What would be my next step? Elijah, any thoughts there? Yeah, and when I did that, what would that produce when I distributed it to both?
Yeah, that would be 4 and 1 over 5y.
Good.
It can't be 20 over 2 though.
And I'm just writing the rest of it. Okay.
Figure it out.
All right, keep going. Anything else we can do?
Do you get a common denominator?
You could. Oh, sorry about that, Thomas. I thought you were talking to me.
Do we need to?
Yeah, that would be a good idea. Improper fractions is perfect. Yeah. Oh, like this? This would be. That's just a little bit off. Yeah. Try to see where you. Just the common denominator, I think. That's what it was.
No, wait, no, it's not. It's negative 2. Then you multiply.
Yeah, so this should be negative 3/10 equals this, right?
Negative 3/10 equals.
Negative 2, right? And then I multiply by the reciprocal.
Light is
And then that's where.
I know. Major
It equals 2 that are added.
Yes, so you have negative 3/10 x equals 8, right? Or equals negative 2, that's what it was. And then you multiply by the reciprocal of negative 3/10. Perfect. And then there you are. Okay?
Wait, so do we leave it as a fraction?
Yeah, what'd you get as your fraction?
I'm not done yet.
Yeah, you'll leave it as your improper fraction. Absolutely. Elijah, did we do this yet?
I thought it was because it was negative 3 and
Oh no, well you could. That would have been at the original spot. Keep going here. Okay? How do I get this 4 to the other side? Good.
negative 2.
So we get this over here
So
equals 4, right?
negative
Okay.
20.
How do I combine these together? How do I add or subtract two fractions?
2x minus 5x.
Great, and what's the common denominator here? 10, good. So if I change this to a 10, that 5, if I do that to a 10, I could, but what did I multiply by? So what do I have to multiply the top by? 2. What about this one down below? What would this change to? 1/2.
5/10.
Great. So negative 2/10 plus 5/10 equals.
First, we need to get an answer for 0.
This one's negative here,
I'm just gonna
so that would be
boxes.
No.
3/10. Great job. So, can I do this? Can I put it up here so you can see a little bit better? So what we have here is 3/10 y equals 4.
20 plus.
Okay? Does that make sense there? How do I get rid of that 3/10 on the left side? We divide it, or we multiply by the reciprocal, which is the same thing, right? And if I did that,
Y minus
what do we get?
minus 20. 4 times 10.
Which would be? This is like 4/1, right? So we just multiply across. So 4 times 10 is 40. 3 times 1 is 3. 40/3 would be my answer there. Okay?
You're subtracting.
Oh yeah.
Hey, as y'all are doing it, is there anyone that's struggling on it? I know I've been doing it up here. Any part that you're kind of a little bit off on? Emma?
When you get like the y value, when you get the 40
What are the answers?
what equation do you plug that into?
Good question. I always try to do the easier of the two options. Both will work. I would do the one that's on the bottom, simply because it's already equal to x. So if I substituted 40/3 in for y, this would be 20 minus, substitute back in, 40/3, and that would equal what x would be there. And then over here, you could get a common denominator. Very good. Okay, you're welcome. Elijah, did you get that, how we get x now? We just substituted back in. We're okay. How does that feel?
I just said sleep. Oh,
No, yeah, so it would just, the sign, you just have correct. Because a negative and negative would be positive. But the answer for x is positive 20. Okay? Elijah, you good here? Common denominators on this? Are you okay on this? Say again?
And you're supposed to factor this, and then
Yes.
you get the.
Is that what you got? No? Did you get here? When you substituted it in? So you're substituting 40/3 in for this original equation that you changed,
I'd
right?
say
And when you do that, then you can get a common denominator in rock and roll, right? So what would be the common denominator here?
I think so.
3. So if I put a 3 on the bottom, what does the top change to? 60. Good.
I haven't seen that.
So 60/3 minus 40/3 would equal what? Yeah, and that's how we get that there, okay? Does that make sense? Cool. Do you wear contacts?
Yeah.
You wear glasses? Yeah. I was just curious on your eyesight there. I was your age, and I was like, I always thought that I could see, and then I realized, like, I need an eye test. And then I went in, and I was like, oh man, I didn't realize. What's that?
Me too.
Yeah?
When I broke my glasses, still haven't got new ones.
Gotcha. Well, if you ever need to, just because I know, I try to write a little bigger, but sometimes I know it's still not good enough. You can come closer if you ever need to. Okay.
So those are the two answers?
These are the two answers, 20/3 and 40/3. Okay? All right, are y'all good? No. Did you get one?
Yeah. I got 20 over 3. Yeah.
For the next one?
Because you're subtracting. Are you doing that?
Oh.
Yeah, I said.
Paris, did you get yours? Oh, I know mine. Over here. When you do this part on this side, this should be negative 3/10. So this should be all positive. So since this is positive 20/3, that would get this off. Yes, so this 20/3 should be what your process is.
Too wild on that.
Awesome.
She like. I was gonna say.
All right, hey, do this for me. The graphing side of it, if you could take out your calculator, okay? How many of you do not have your calculator? I'm not going to humiliate you here, okay? If you are going to, if you don't have your calculator, could you take out your Mac real quick? And instead, go to Desmos graphing calculator. Just Google that, and it should look something like this, just so that you're kind of getting the rep of what we're doing. But go ahead and do that there. I want to show one quick type of problem that relates to your homework. So we're going to do one together, and then I'll let you kind of work on the other three off your homework there. So take out your graphing calculator, and to graph these, where do we go in order to graph equations?
Table.
Y equals, right? So we're going to go to y equals, and instead of having whatever equations are in there, we're going to put in two different types of equations, okay? So we're going to do one rep on this. I'm going to go backwards just a second right here. So ln of x, right? Y equals ln of x is the first one. What would I have to do for the second one? Subtract x, right? So each of these values need to be y equals something, right? Need to be y equals. So we're going to plug both in. The first one will be y equals ln of x, and the second one will be 1 minus x. Good. Okay. So let's go ln. Ln's down below, okay? Does anyone know what that's called? ln. I'll tell you what, I'll give you 6 tickets if you know what ln is called. Mary Grace? The natural log. Wow. That's impressive right there. Good. So yeah, the top would be ln of x, and then the bottom would be 1 minus x. Be careful not to use negative. If I use negative, it won't give it to me, okay? So there is a difference between this negative and minus. I know you know that probably, but just in case. All right, then what do I go to?
Graph.
Graph. Very good. All right, so how many of you have had problems in the past of getting your window to be able to see some of the equations? Anybody? I know sometimes that's been a struggle. If you can't see it on your window, you can always go to Zoom, okay? So Zoom, you could go to Zoom Standard, which is 6. What does that do? 10 by 10. It's like someone was here this morning. Yeah, 10 by 10, right? Both to the left, right, up, and down, okay? Another way to kind of do that too is you could go down here to Zoom Fit, which fits it in the window for you. Sometimes that works, sometimes it doesn't. But regardless, you'll kind of zoom in and make sure you see both equations. Now, based upon just looking at it, does anyone have an idea of what the solution or the point of intersection would be? Thomas?
1, 0.
1, 0, right? Now, are we 100% confident about that yet?
No.
No, I mean, we're pretty confident because it's pretty easy to see it. But just to check it, here's how you actually check this. Go ahead to second
It is 1,
trace. Okay? Second trace. Oh, yeah, you could kind of see it off the table too, couldn't you? It's actually pretty good. Sometimes that does work, sometimes it doesn't. So just a heads up there. But if you go to second trace, go down to which one? Intersect. Good page, yeah. Which is number 5, right?
Wow.
Number 5. Now, this is basic, but I've been surprised at some of the things that Pre-Cal 12 students have been struggling with in terms of their graphing calculator. So I don't want to insult you, but just in case you're struggling. If I push to the right and to the left, notice my first curve is the first question. What do I see when I go towards the right side? Sorry, let me go back here. Let me try it here. Come here again, go to intersect. What do I notice when I go to the right? What is my cursor doing? It's telling me the points and it's going on that curve, is it not? Okay? But when I press up and down, what happens?
It switches line.
It goes from the red to the blue, right? the two different equations. You see that? So up and down goes between the curves. Right and left goes on that same curve, just to the right and to the left of it. Okay? So when it says first curve, I'm just going to press enter here. Okay? What did it do when I pressed enter? Ask for what the second one was, right? Now notice if I go back up to the blue and press enter, it won't let me do it. Why? I just had put it in, right? So I've got to go to the second curve, like Josh had said, and once I press enter, I get a third question, which means guess, right? So what does the guess mean? I'm going to try to estimate that point of intersection, right? So if I go towards the right-hand side, I want to guess where they intersect, in this case, at that spot, and when I press enter, there I go, there's my point of intersection. Okay? So my answer, like Thomas had said earlier, is 1, 0. Okay? This is not algebraic, this is simply using my graphing calculator. How do y'all feel on that? Y'all are okay? So what do I do if I have a parabola? All right, hold on. Here's the pool noodles. Anybody buy one on Prime yesterday? That's what I'm talking about right there. It was Cyber Monday. 2 for 1. 2 for 1. All right, here we go. Hold that right there. Here we go. If I have this and we had a picture like this, how many times would I have to do the intersect? Twice. Why?
Because it has 2 points of intersection.
Yeah, so what would be the difference? The first curve, second curve, or guess? I'll say that again. So based on this, remember there are 3 questions.
Yeah.
First curve, second curve, and guess. Which one would change if I was trying to find different solutions? The first and second curve would be the same, right? Wouldn't it? It would be first curve, second curve. The guess would be the part that you would have to rotate to either this side or this side. Okay? If you're confused on that, I'll be around to help you. Thank you, Grant. Appreciate you right there. And we'll be going from there. If you need some help on some of that, I'll be around helping you out with those ones that are there. Okay? All right, so here's what I want you to do. On your homework, numbers 7, 8, and 9 are all graphing calculator problems. Isolate y for all of them, and then go ahead and plug them in and solve for the specific points of intersection. All right? Go. Let's do this thing. Mary Grace? You may. Plugged in today. Good stuff. You got a good team.
Okay. Yeah, you got the Wi-Fi.
Yeah, what's up, Ty?
So you're not doing the regular.
Oh, when you plug it in? Yeah, look at it real quick. Sometimes it's
Am I gonna invite one?
sometimes if that happens, I go to window.
The first one.
Wait, okay. Here. So what I
Did you have anything
So
on here
what
that's
I-
like, I don't need to erase
got was
No.
You were
Two
you
lines.
like anything on here? Alright,
Guess
just
is
checking.
you check where
When you go to second, plus,
and then you divide.
you know you could have games on here, right?
So two
I
divided by
did.
two.
You know, like
No,
Mario
it's-
and stuff.
That's
why I tried when I asked.
Yeah, I'll probably try to
Oh,
One
one.
try it.
Push,
Try that one more time.
push J.
Okay. Sometimes it messes up in the function on the calculator.
Push J.
Pretty either.
Yes.
Do you
That's
wanna do
good.
something?
Good stuff.
Okay.
That's right.
For that first one. Was he being sarcastic?
It's already.
I'm pretty sure he was. I think he was low key trying to get me there.
What did it say?
So you put one.
Yeah, absolutely. Go to second count.
I don't think you
Go
ever
to second
you
count.
do
Go
it.
to the home. Where would I go from here?
The first one, yeah.
That's fine. What's nice is
And you do second trace.
because you can see that it's actually on the red. It's just way up here. So if you push to the right,
And then you do
it'll
like, you do that on that line, so you hit it. And then you do on that third, so you do that. And then you try it.
And so on that one, you can just press enter as long as it's on the red.
So it's 1
Just go to
minus
the second. Now this next one, the guess is where you want to try to get as close as possible to that intersection by going right.
It should say x equals a y equals.
When you press enter, it should give that to you. Get that intersection.
You walk away.
So there's no algebraic method that you need to use in order to do it, though you could do it that way. Graphing is just another way of finding it.
You used to participate in your sarcasm.
Good stuff. Yeah, Elijah. Gotcha. Do this one. You need to isolate y for both of these first. So just get y by itself because that's the first step when we graph these. So get those first, and then we can plug them in like that. Cool.
Because I have one. So I will. Because I have to take it.
Yeah, hey, y'all don't have to do a picture of these because we're doing them in class. I'm just coming around. I just want to make sure you know how to do it. You know? So as long as you're checking with me and doing it, I'm good. Well, if I'm getting 5 by 3, right, I'm not going to do 5 by 3 because I'm going to bring all 3x over here. So I'm going to get 3x.
Wait, which one?
Subtract. The only time I need to divide is once I subtract 3x, it goes down.
There was, I think it
Oh,
was,
you got it.
it was like in the
Does that make sense? So just subtract 3x.
I don't know what it's gonna be.
I got scared.
So first
You just press enter on that right here.
Where you get
Second,
two,
but
but
usually
oh, it's 1. Because you divide the 2 by 2 walls.
Yeah, it's all the big stuff. Why is it right here? Yeah, so it'd be, yeah, we'll just make sure you're trying to get that to where it's close to about 3.5 or so. So remember, up and down goes between the two curves. Right and left kind of goes on the same way, right? So right now you're at 32.29. So go to the right, lowering it.
I was for a time, and then I stopped playing. Taking a picture.
Yeah, so when we do, I'll show you on here just because it's weird. Isolating y is the weird part, in my opinion. So if I were to get x squared plus y squared minus 4x equals 0, how would I get y by itself? Yeah, so subtract everything but y squared, right? So x squared, add 4x. I do that to both sides. So I get y squared is equal to 4x minus x squared. Cool? How do I get y by itself now? And when I square root a squared, not only is there a square root over here, but there's also a, great job. Again, someone must have been here this morning.
No, it's Ken.
Kennedy, never mind, my fault. Kennedy's correct. So it's plus or minus, right? So here's the weird part. With this equation, I think you get this one, right? Like isolating that one. This one down below will actually have 2 separate y's. So this top one would be y1. One of these would be y2, the positive one. And y3 would be the one that's negative square root of 4x minus x squared. Does that make sense? The reason why you have plus or minus here is because when both are squared, you know what the picture would be? Circle. Where the positive one would be the top, the negative one would be the bottom, and then the line would just go through it. Does that make sense? Cool. That one's a tough. I thought that one was a tough one too. So that was tough too. So you got this little bottom one, right? So we have 2y, right? We got y by itself, right? This one would be plugged into y, the bottom one. Guess 2, don't we? So we get y by itself on the top.
4 minus x.
No, I know, but,
Good, and then how do I get this y by itself? What would I do there? Divide by 2 on both of those, good. So this would be y is equal to
Oh, plus
2
or
over
minus,
2
yeah, yeah.
plus x over 2. Right?
If you.
Because the 2 goes to both, right?
yeah.
And then what you can do is plug in both of those equations, each separately, into y1 and y2 on your calculator.
Oh, you're where I'm at. I'm sorry.
Then you're gonna go here, right?
I feel like we can do it yeah.
Right here. You'll put the first equation here and the second equation here.
I'll see.
Does that make sense? So plug those in and I'll help you. I overheard a little bit what y'all were saying. What were we struggling on?
When you take the square root for y squared, what do you do with the like 4x minus x squared?
Oh, right here, inside? Keep, literally, it's kind of nice because you can just keep it on your calculator. So you'll just put it as square root of 4x minus x squared.
Right, so we have to divide 2 different y's.
For this one, because it's a plus, the first one, and then the second one would be negative 4x minus x squared.
So we're plotting 3 y's.
Correct. Really, it's 2, but your calculator can't do plus and minus. At least not that I know of.
So it's 4x minus x squared inside, and I keep the plus and negative outside.
Correct.
So that's how I need to put it in there.
You
Kind
can
of with
put
the
one as positive,
intersection.
and then the third one.
What equations did you, that's not even
Like
So the
Did
top,
you get
the third one would be negative square root of.
x plus
What they
3,
Oh,
and then you just plugged in the
I have to put it outside of the.
yes, so you put a plus here and a minus here.
At
They
the
should
end of
both
the
be
game,
negative.
plus
and minus is almost right.
That's where it's
Wait,
Wait, I could
Maybe that's not really
Are y'all good over here?
I was like,
Is this supposed to look like that?
Yeah.
And then I think
See,
zero,
if you go to y equals, that's pretty close actually.
because that's where those two.
How'd you get the x plus 3 again, Sophia?
Wait.
this part,
One thing was that
like,
the negative one.
Oh, you're on number 8.
Yeah.
Y equals x plus 3. That one's perfect.
Okay.
The one below, the second one, it's kind of nice because this is already y equals this. Whatever you see, just plug that in.
Oh, okay.
The one that we're doing, you might have overheard us, was on number 9, when you have to square root it. Over here you don't, because it's just y by itself.
Okay.
Does that make sense?
Is
Is that number 8?
that right? Wait,
What'd you get for your line?
Really like
what do you mean?
complaining.
You didn't get stuff.
I need to stop.
When you
Wait,
change
I
it
really
around.
just
And then once you do that, that should be,
It's okay, just leave it, because I was wrong.
and then once you do plus 3, you'll see the intersection.
It really bothers my heart.
Are you fine with the x?
See, the first point
Correct, it's not, what I would say is,
Oh,
see
my
that
God.
0 there?
That's why you-
It's the one on top first.
Yeah.
So to do that, you have the first curve, the second curve would be the top of this, and then the rest would be this side. Does that make sense there?
Like she was.
That's how we
She was.
would do it. Did you get it on that part?
Oh.
So what we've got here is this, right? This first one is 15 minus 3. So how we plug that in? You go 15 minus 3, and this x is where it is, right? Alright, down below, this one is 1
Oh, that's
plus
it.
1 half x. So we would just say 1 plus, I usually use, same as 1 half is 0.5, right? So couldn't we just say 0.5x? Right there, we're just gonna go to graph.
Yeah, so.
She knew. I'm still solid. So I was at that game.
One.
Like, they were in the student section. No,
One plus 5x.
Or is that help us
No,
with the calculator? Okay, so that's equation 1. This equation 2, right?
Second curve.
So go ahead the second trace real quick. Second trace, go down to which one? Which one we go to on that one? Intersect, good job. So you're good there. And then once I go to intersect, you'll ask first curve, second curve, and then the guess, alright? So when you say first curve, go ahead and intersect there. Press enter there.